One or two formula to remember. Sin x over cos x equals tan x, and sin squared x plus cos squared x equals 1. Now there are a number of variations on this number 2. If I subtract sin squared x from both sides, I can get cos squared x equals 1 minus sin squared x. And if I go back to this line here and subtract cos squared x from both sides, I get sin squared x equals 1 minus cos squared x. Example 1, simplify 3 cos squared x plus 3 sin squared x. What I'm going to do then is take out a common factor of 3, and this here above is this equation. We've got sin squared x plus cos squared x, so that's 3 times 1, which is 3. This is the line that I want you to look at here. So what we have is 1 minus cos squared x equals sin x. Slide 1, so we want a replacement for sin squared x. Well, here it is, we've already used that in an earlier slide. We can replace sin squared with 1 minus cos squared. Example 2. 4 tan x divided by 2 sin x. Now, 2 divides into itself once and into 4 twice. So, I've got 2 tan x. I'm going to change the appearance of it. Instead of having sin x on the bottom directly underneath the tan x, I'm going to write it like this here. There's a reason for it that you'll see in just a minute. So those are the two are the same, but they just look slightly different at the moment. Tan x, remember, can be written as sin x over cos x. And here is the dividing sin x. Now I hope you can see why I did that. It should now become clear. We've got a sin x on the top. That's going to cancel out with this sin x on the bottom. So what do I have then? Well, I've got 2 on top and cos x on the bottom. Example 3. I'm going to take out 8 as a common factor from both terms on the top line. Now, if we go back to slide 1, 1 minus cos squared x, which is to say this here, that can be replaced with sin squared x. So top line becomes 8 sin squared x over 2 sin x. 2 divides into 8 4 times. Now, remember, sin squared x is sin x all squared. And we've got a sin x on the bottom line, so when we simplify, the sin x on the bottom line cancels out with one of the sin x's on the top line. What are we left with then? 4 sin x on the top line. Example 4, 3 sin x cos x over 6 tan x. We want to simplify this as far as possible. Well, I suppose what we can do is divide 3 into itself once and into 6 2 times. So I've got sin x cos x on the bottom. Now, I did this with one of the earlier examples. I'm going to move the tan x to one side and write it as 1 over 2 tan x. That's the first thing, so I'm just changing the appearance of it. There's my sin x cos x on the top line. Remember that tan x can be written as sin x over cos x. Dividing by a fraction, which is what I've got here. I'm dividing by this fraction. Now what happens when you divide by a fraction? You change, so you leave the top line unchanged. Let me just do it over here. You leave the top line unchanged, you change divide to multiply, and you turn the dividing fraction upside down. So what we had, what was originally 2 sin x cos x becomes cos x over 2 sin x. So 1 times cos x is just cos x. So that's what this part becomes. So cos x then over 2 sin x. Now you can see we've got a sin x on top, sin x on the bottom. I've got 2 on the bottom, which is a half, dividing 2, and I've got cos x times cos x, which is cos squared x, and that's as far as this one will go. Now this one's slightly different appearance. What we want to do is to show that the left hand side equals the right hand side. So what I'm going to do then is start off with the left hand side. I'm going to write it unchanged. The left hand side is 2 cos squared x plus 3 sin squared x. Now let's look at the right hand side. What do you notice? We do not have a cos sin squared x. So we're going to have to find a replacement for that. And if we go right back to so we can replace sin squared, not the 3, we can't replace that. Sin squared can be replaced by 1 minus cos squared x. So that's 2 cos squared x plus 3 minus 3 cos squared x. You'll notice we don't have any sin squared x terms now. What we can do now is gather together like terms. Well, here's one like term, 2 cos squared, and here's another one here, 2 minus 3. So what I'm going to do is take the 3, this 3 here, so 3. 2 take away 3 is minus 1. Or we can leave out the 1, which is exactly what we have on the right hand side. Example 6, we want to show that 1 over tan x plus tan x equals 1 over sin x cos x. So the left hand side is 1 over tan x plus tan x. Now we know that tan is sin over cos. So I'm going to replace tan x with sin x over cos x. Now look at this first term here. In an earlier slide I explained what to do if we divide by a fraction. That's what we've got here. We're dividing by a fraction. So we leave the top line unchanged, which is to say it's a 1. We change divide to multiply, and we turn the bottom fraction upside down. So instead of having 1 over sin x over cos x, we've got cos x over sin x. The second term does not change. Now just to tidy things up, I'm going to get rid of this 1 multiplied by. We don't need that. So I hope that's important. So 1 over sine over cos is cos over sine. In the same way that if we had a fraction, 1 divided by, let's take a nice simple fraction, 1 divided by a half is 1 times 2 over 1, which is 2, which is to say there are 2 halves in 1. What about another fraction? 2 divided by 3/4, that's 2 times 4 over 3, which gives us 8 over 3. So you change divide to multiply and turn the bottom fraction upside down. Now, what do we need to do? I hope you've seen this technique before. We're adding 2 fractions which have different denominators. So we can multiply the denominators and then proceed like so. Those are multiply lines. So sin x times cos x on the bottom, and then what was it? Cos x times cos x, which is cos squared x, and then sin x times sin x, which is sin squared x. And I hope you can see we've got cos squared plus sin squared on the top, which is just 1. Sin x, cos x on the bottom, and that's exactly what we have up here. So I can finish off by saying that's equal to the right hand side. Example 7, we want to show that the left and right hand sides are equal. Now, I've got quite a lot to do with the left hand side, so what I'm going to do is to start to expand. I'll tell you what we'll do. Yes, we'll just do it like so. So I'm going to write the double bracket. That's what the square means. We have 2 brackets multiplying. Now I'm going to start to expand. I'll show the multiplication for the first 2 brackets only. So 2 cos b times 2 cos b, that's 4 cos squared b. Then 2 cos b times 3 sin b, 2 times 3 is 6, and that's sin b cos b. And then these 2 multiply, that gives me 6 sin b cos b again. And the final 2 terms from this pair of brackets, 3 times 3 is 9 sin squared b, plus the second set of brackets, 3 times 3 is 9 cos squared b. Now, well, I wasn't going to show these lines, but maybe I should. So that's the first 2 that we did. Then we've got to be careful here because we've got 3 times minus 2, so that's a minus 6. And it's sin b cos b, or cos b sin b, that doesn't matter. We can put the sin before the cos or the cos before the sin. Then we've got these 2 multiplying, so that's another minus 6 sin b cos b, and finally these 2 terms here, so that's plus 4. Right, we're all ready to simplify. Now, look what we've got. Here is plus 6 sin b cos b, and here is a minus 6 sin b cos b. So those 2 terms cancel out. here's another plus 6b, plus 6 sine b cos b, and minus 6 sine b cos b. So these two terms cancel out. That makes life a bit easier. What I'm going to do next is I'm going to put that, well, let me just put this term at the front, this term, and this term. So that's 9 sine squared b plus 9 cos squared b. Then I'll put the other two terms, here they are here, this one here, followed by this one. That's 4 sine squared b plus 4 cos squared b. Now I can take out 9 as a common factor from the first two terms, and 4 as a common factor from the second two terms. And remember, that just equals 1, and that just equals 1. Sine squared plus cos squared. So what have we got? We've got a 9 plus a 4, which equals 13, which is exactly what we had on the right hand side.